Welcome to the part 2 of this air quality data analysis project, building dataset in R. If you missed, check out the previous video, which was part 1 of this project. So we are going to handling missing values. We saw that in the previous session, we identified missing values in these particular data sets. So how can we handle these missing values? We have two columns that have missing values in our data. So there are different ways of removing values. And maybe for this just particular session, let's say there are different ways of actually handling missing values. We have ozone concentration and we have the solar radiation. Yeah, so there's no best way of handling missing values every time, but there are different approaches of handling missing value. So for this session, to just make our analysis move forward with no missing values, we are just going to use the first option, which is usually removing missing values from our data. However, you can handle missing values by using the mean. Okay, you can do data interpolation. You can do fill forward approaches. You can also fill your data with mode, fill your data with median, depending on the circumstance that you are on. However, for this particular session, we are going to use the dropping missing values, or the data that has missing values from our analysis. However, that is not usually like the convention that you must always use to handle missing values. You can see our dataset has 153 observations. When we drop 37 observation, that means we are minimizing our number of observations. And remember, we also have 7 observations that are missing the solar radiation. So we can always find which way. However, just for the purposes of this session, this time around, let's handle them just by dropping these missing values. And then let's see. So missing values is usually good when at least in a row, like across the row, there are more, like it cannot be a representation. The missing values in that particular cannot be a representation of the true picture. However, the advantages is that at least the remaining data set will, of course, be the exact as per the initial collection. The disadvantage is that you will have reduced sample size of your analysis. Now, let's proceed and see. Now, the first option, which is now to remove the option 1, which will just use that for this. We will also explore other ways of handling missing values in other projects. So we'll also learn those other means of handling missing values in other projects as well, so that we can see different ways of handling missing values and which one is appropriate during which scenarios. So we are going to create a new variable called air quality clean, which is going to store the clean dataset, that we will have obtained after omitting the missing values. So na.omit is a method that helps us do away with missing values in this particular dataset and remain with the clean data. that has no missing values. So when we just run this, we will have created a new variable called air quality clean. You can see in the variable environment. And it has now 111 observations and 6 variables. That's meaning that this is our new dimension. You can always check also this dimension, as we saw in the previous video, that you can use a dim method to check for the observations we have in our data. Okay, so this one also will return that now we have 111 missing values in our data. Let's perform some now descriptive statistics for specific column intervention. Let's say first we obtain the mean quality, mean quality for mean ozone. So you can call a specific variable in the dataset and compute its mean using the mean method. So let's perform some summary statistics. So the summary statistics, this is not summary, but let's call it descriptive statistics. Descriptive statistics. So descriptive statistics will start with, let's say, mean. So we understand that descriptive statistics is split into two. One is the measures of central tendance, which we call the measures of the center of the data, and then we have the measures of variation, which are called the measures of spread. So we'll start by exploring the measures of central tendency. So air quality, we call the dataset air quality. Of course, we are now dealing with clean, and then we call the variable name for this dataset, it's ozone. So when we do this, we will have computed the mean for ozone. So ozone has a mean of 42.0991. Initially, what was the mean for ozone before handling missing values? When you look at the mean, initial mean was 42.13. That was the mean before handling missing values. And you can see is not as well far away from this mean after handling missing values, meaning that even also mean could have been a good representation of this particular dataset. However, you can plot, for you to check, you can do a histogram. Okay, you can do a histogram of the respective dataset and see if actually mean can be a true representation of that particular data. You can do a histogram to check if, let's say, let's see. We will come to data visualization where we'll do more of the histogram. Let's say we try to build the histogram for air quality before the okay, let me see. So air quality ozone, I didn't call the ozone variable. Ozone variable. You can see how this data is distributed. You can see how this data is distributed. The ozone and the way it's distributed is not that normally distributed. Let's see east air quality, air clean, then we call ozone, and let's see, we can compare this one and this one. So see, that's a small variation. So this kind of data is not, cannot say that it's normally distributed such that we can use the data output as like the mean to be the true representation. Remember, mean is around here. However, you have days that the ozone went to up to, you can see the maximum value was around 200 and something. So using the mean, which is around 43, could not be a good maybe reflection of other number of days. Maybe now for such like scenarios, maybe slight variation. There's usually slight variation actually between today and tomorrow. Remember, ozone concentration depends on temperature, wind speed, and so on. So representing with the mean might not be a better representation of this particular scenario. You might use the approaches of either forward fill or backfill. Forward fill, backfill, meaning that at least the variation between today and tomorrow ozone concentration might not be that different. In some scenarios, in very rare scenarios, where you will get that it happens to just go otherwise. So mean cannot be a better representation. That's why, because we didn't have more insights on this data, we decided to drop all the missing values. However, you can see now the forward and the backfill now idea comes in such a like scenario. So as I mentioned when we were handling this, that you cannot be able to use just any of the methods. So we have seen the mean. We will come to visualization later. So we have seen the mean of our data, and then the median. Let's check the median for this particular data set now, the new data set. So median is also a measure of central tendency. Median is a measure of central tendency. So air quality clean, and we're going to call the ozone. Okay. So when we execute this one, we see the median is 31. What was the initial median? 31.50. The median is 31. Okay. Now, of course, that's now arranging the data and looking at which one is actually at this middle point. If they happen to be 2, then you do the division. Now, we have some, we see, you have things like range, the measures of spread. Measures of spread depends on things like maximum. So we can check the maximum value, air quality, clean, maximum value, air quality, clean, ozone, for instance. But of course, you can explore other data sets as well. Ozone. Okay. So this one returns as 168 is the highest maximum value. The minimum value is, you do also the same. Zone. So the minimum value also do the same. So if you were to compute the range, which is usually the measure of course also is part of the measures of spread, the range is obtained by getting a difference between the minimum and the maximum value. And now, once you have the range, you might also now need maybe to perform some first quantile, some third quantile, and of course, now be able to perform if you were to check for outliers. Like you can see some values are actually weird observation even up to 1. And so you might be, instead of looking at these outliers or not, so such like scenarios, you can always simulate such situations and be able to handle your data really well. However, as part of measure of now spread, you can check now the standard deviation. How far away are these observations from the mean? Very interesting to know the measure of spread. Okay, so maybe we can do that for ozone concentration. You can see 33.27597. That's a very big variation. You can see the highest value is at 167. The minimum value is at 1. And the mean is at around 42. So that variation is really, really big. When you look at how far away are the observations from the mean, from the center, shows that it is a very big variation. So that also still explains why mean cannot be a better representation of this scenario now if you're handling missing values. Okay. Yeah, so thank you so much for how to handle missing values. Now, in the next part, in the next video, we'll be looking at how we can do data visualization with this data set. Thank you and see you in the next part.